Hi again, everybody. It's Adrian from the Sofeast team here. You are tuned into China Manufacturing Decoded again. Thanks for joining us. It's episode 113 now, and I'm joined by our head of new product development, Andrew Amirnovin, and you might have heard him on the podcast before, so he's a repeat guest on the podcast. And Andrew is joining me today to talk about what needs to happen in order to go into mass production. And you cannot go into mass production unless you've done what he's going to talk about today. Andrew, you've worked in some of the world's biggest electronic companies for decades, and you've got a lot of experience. It's so great to get you on. How are you doing?
Doing well, Adrian. It's really good to be here. Thank you very much for the warm welcome and great introduction. Really appreciate it. Yeah, I think that this topic is one that a lot of people who are thinking about, developing a brand new product, they just kind of get confused. Where should I start? What should I do? When is the right time to go to mass production? How much is it going to cost me? There are just so many questions in this area. I thought it would be a good thing that if we kind of help our listeners in this regard.
Yeah, absolutely. We've written about the process to get to mass production in various written content. We've spoken about it on the podcast also, but I think there's often some confusion about, my prototype looks like it's meant to look, it works like it's meant to look. Can I just go into mass production now? And the answer is, it depends, and it's really not simple, right?
Yeah, exactly. I mean, the development is a very complicated process, and if you want to do it right, with quality and reliability in your mind, you really have to take care of a lot of things before you go to mass production. One of the important things that I think that a lot of people forget is validation. And then there's another term that most people get these two kind of confused, and that's called verification. A lot of people wonder, validation is the same as verification, or verification is the same as validation, or can they use vice versa? And I think that it would be good if we can kind of clear this process, these two terms for our listeners. And then we can get down to help them understand what it is that they must do before they go to mass production. Well, let's put it this way. Validation means really testing, making sure that you validate the product by some sort of testing. And I'm really oversimplifying it, because in some industries, for example, medical device industry, validation and verification are very clear processes. But in consumer electronics, really almost the same. The terminologies have very little differences, because validation by testing, it means that you really have to have set of test cases, goals for trying to figure out if it can pass this test, if it can pass that test, and so on. And that could be any kind of test. In consumer electronics, it could be drop test, it could be vibration test. In a medical device, it could be some kind of virus that you're testing, and there's a whole bunch of other maybe FDA level tests. So it depends on what you're doing, but typically validation means some sort of testing. However, how would you say that is different from verification? Well, verification is the process. Once you have validated by testing, now you have to analyze the data, and you have a whole bunch of tests that you have done, and you have to come up with some kind of conclusion and approval process, and that's called verification. Does that make sense?
Yeah, it does. Interesting. Okay. So there's a lot of different types of validation and verification out there, aren't there? So, because if we look at validation as testing of the product, as you mentioned, there may be a lot of tests that need to be done. You know, food contact products may need a lot of FDA tests to make sure that, I don't know, the plastic that you're using is actually safe for use to contain foods and things like this. That's just one example. There could be many, many different types of tests. And I suppose another key question that importers who are trying to develop and bring a new product to market, whether it's electronics, as you've mentioned, or other consumer goods, is, okay, fine. We know that we need to do this validation verification. You know, that we know that there's a lot of testing, but what's right for us? So it might help to talk about the different types of validation and verification that are out there.
Well, let me just make something clear to our listeners. So I think that we wanted to let them know what it is that they must do before they go mass production. We talked about You can't go mass production unless you do this. And what that is that they must do qualification of the product. Okay. So how do you qualify the product? And how you do it is by way of these two processes, validation and verification testing. So if you have done validation testing and verification process, you have done these two, then you are qualifying the product, and the product is qualified and it's ready for mass production. Now let's talk about different types of validation and verification. So
good.
As you go through the product development process, you are really going through design process. You are going through analyzing a whole bunch of components and deciding suppliers. And then finally, your product is ready. So you're actually trying to validate your product. And then you have to go to mass production, and you validate. Before you go mass production, you have to validate your production line to see if it's actually feasible and can produce this product. So the process that you have to go, let's talk about the design, for example. You need to have design validation and design verification process. And typically, when it comes to design, you have a whole set of tests. Typically, is called physics of failures. You know, when it comes to, for example, some sort of quality or reliability testing that you have to do on that product. It could be anything. It could be drop test. It could be a test of failure. It could be a halt test. It could be performance and specification tests. Any one of those are physics of failure tests that you have to do to validate the design. Is the design meeting the minimum specified operating conditions? Where is the limits of the design? For example, under certain the voltage and current conditions, what happens if you increase the voltage, or there is a ripple effect in the current, and all of a sudden the changes in the voltage, is it going to shut down or create the dangerous conditions in the product? So all of these need to be tested to validate that the design is reliable and is sound. Then you start going through verification process. That's when you have all the data for every aspect of the design. You know, for example, design quality, design for higher voltage, lower current, higher current, different environmental conditions for your design. What happens if your, for example, IC overheats? What happens if your PCB overheats and all the components are hot? What happens if there are cold conditions? So actually, designers really literally take their PCBs and put it in a chamber, and they cool it, and they take measurements, and they heat it up, and they take measurements, and they want to see which components actually failed or which design part didn't function, and that they need to improve. So once they have fixed all of those issues, then basically they have done the validation process and they have done the verification process. Then that design is ready to move to the next level. Now, one of the other things that you have to do through that process, as you know, Adrian, components and suppliers, you have to validate and verify both of these for every new design. I think that one of the things that is very important for every product design or manufacturing is to make sure that they choose high quality components and reliable suppliers. And to do that, most often they have to do what they call supplier assessment and component validation and component verification. And so since we're not talking about assessment, so I won't go to that direction, I'll basically focus on component validation. So what they will do, the designers, they typically have a very good component chosen initially because they really want to validate the design. So typically they don't pick a component that has a very wide tolerances at the beginning of the design. They pick one that is reasonable tolerance, and they want to kind of control the variability of the specification at the beginning. And then by doing this, they perfect the design. So the point here is that you need to make sure that your components are validated for design in terms of performance, in terms of design specification. For example, if your design must be operating at high temperatures, you want to make sure that your component is also going to be able to handle that same temperatures, or maybe even better than your design specification. And then in that retrospect, you want to make sure that your supplier is aware that you have these requirements for your component, and that they should not deviate from those requirements. So once you have good components that actually meet your design validation and design verification requirements, then you have already improved your design.
You wrote about golden samples recently on Agilian's blog. Once your product has gone through all of the validation and verification, so you've qualified it, would you consider that to be a golden sample then?
Not necessarily. Golden samples are really very unique, meaning that typically they are almost what I call perfect samples. And we don't really live in a perfect world, and no design is perfect. And if we had to make the entire product from golden samples, it would be a very, very expensive product. To give you an example, let's say you have a design where every single component has to be a 1% tolerance and nothing more. Well, then if you put, for example, a 10% tolerance component, it won't work. And then any component that is 1% versus 10%, then that means it's a very precise component. And being precise it means that it's going to be very costly. So in many cases, golden sample really is the indication of what the desired specification should be and desired performance of that part should be. But in many cases, we can't meet those requirements for every component in there. But what we talked about, I think, in the past, between the differences between golden sample and the limit sample, was that golden sample is something that indicates what for example, if you want to test a product and you want to make sure that it's operating within the specification, then you have chosen a sample for your testing purpose that is a typical example of what the normal sample would be like. So golden sample does not necessarily have to be like a, perfect sample. In terms of tolerance. So you could have a tolerance of 5%, which is a typical of what the components that you purchase. And you would say, okay, this one is a good component. We call it golden sample, meaning that it passes all the time and it meets our requirement and it's within our specification. However, the failures spec is all clear when you're testing. In other words, for example, you take the golden sample and you put it there, you're reading certain parameters, and then you put another sample in there, and then all of a sudden you're failing because it's not within the realm of what the golden sample performance would be. Okay. And again, the word perfect does not mean that it's perfect as in the sample, but perfect for the product in terms of meeting its specifications. I don't know if that makes sense.
Yeah, it does.
Going back to another thing that I wanted to kind of add here was product validation, because really what you're trying to get out of this whole product qualification is to get to production, mass production. And yes, your design is good. Okay, you've done validation and verification. Your components and suppliers are good. You've done validation and verification. But now you put it all together. You put it in a box. You have to test the product, and you have to validate it, and you have to verify that everything is in the right order within the performance specification and so on. And so product validation means you have to do a whole bunch of other types of tests that are totally different than the design. For example, in the product level testing, you have to do user experience testing. You have to do reliability testing. You have to do assembly level testing. How are they going to actually, for example, if there's minor assembly is necessary by the user, to be able to actually do user experience. And they call it, sometimes we call those ecosystem testing and software testing. And then you have to verify all of those tests and results to come to a conclusion that the product is ready for mass production. And then before you do mass production, I don't know if you have ever heard of MPI line in production. MPI line is a very typical line, a production line that is just dedicated for new products that are coming online. And so they actually have a special team in production that are familiar with brand new products. They know that the product is going to have all kinds of issues. They are very experienced assembly team members that they know how to work with the engineers in terms of setting up the assembly line balancing the assembly line, what jigs and automations are required, timing the assembly process, how long it takes to assemble, a certain section of the design, for example. And so this team, basically, their role is to take the product and do all these activities, and then at the end, deliver a full product. And in doing this, they have to do line validation. For example, how long does it take for these materials to start from the beginning of the line and get to the end of the line? And then, is that too much time? Is that just the right amount of time? Is that too many people? Or one person is working harder than the other? There are so many issues of resolving, how a perfect assembly line would be that's working like a clockwise. So you have a lot of manufacturing engineers, design engineers, quality managers that work together to make sure that the line manufacturing new product introduction line is actually ready for manufacturing. Once that process is ready, then the verification happens. And that means that they basically start the clock and they say, okay, go. And the manufacturing material is passed on to these assembly line employees, and they get to work full speed. And then at the end of the line, a product is born. And then that's where they say, okay, it took this much time to build this one product. How many can be built per day? So that is just one element of the, the qualification process. So that's called manufacturing line qualification, which entails validation and verification. There is one more item that is very, very important and more often forgotten when to do, and that's called compliance and regulatory qualification. And that's really critical, yes, because I don't know if you heard of FCC.
Yes, absolutely. So I mean, it's almost essential for electronics, right? Especially those that are going to be imported into the States or North American market.
Right, but that is just one of many other compliance and regulatory requirements. Depends on depends on what kind of product you have. If you have, for example, electronics product, consumer electronics, then you have different kind of regulatory requirement. But if you have medical device, then you have definitely different kinds. Perhaps you have FDA requirement. In the electronic device, you have FCC. If you have, for example, Wi-Fi and or Bluetooth that are or RF devices in your product, you could have requirements for US, for example, California Prop 65, which says basically you want to make sure that your product is not hazardous to the environment. And then you could have Europe, if you want to sell it in Europe, which you could have a RoHS requirement, RoHS, which is basically very similar to hazardous requirement for California, meaning that basically you want to make sure that you don't have hazardous, dangerous, like lead in your product. Then there's a whole bunch of other requirements depending on the country that you want to sell your product. So can you imagine you produced your product, you've done everything perfect, but you just forgot to do compliance and regulatory requirement test? How can you sell that product? You cannot. You cannot import it even to any country. I mean, you could just make one mistake and then all of a sudden, everything comes down. And there's always a right timing for doing these products. For example, if you do it too early in terms of compliance test, maybe it's costly. Then you have to do it again after many things have changed in the design. If you, for example, you had a Wi-Fi chip that you did your compliance screening, and then all of a sudden later on you decided that we need to go with a little bit of high power or a different kind of a Wi-Fi chip. Guess what? You have to do full compliance test again. And so timing is critical on these. So typically you make sure that you consult with compliance lab or compliance engineer who knows exact timing by experience and or by the regulatory requirements, and they will kind of make sure that you do the testing, and that's called validation. And then once the tests have passed and meet the requirements, then that's called verification, and the two of them together is called compliance requirement meeting the requirements, meaning that it's qualified. Compliance is qualified.
Someone listening might be thinking, where do I start with all this? If they don't have the experience to put all of this together, what's the sort of starting point?
Well, that's a great question. I think that the way we work, of course, in engineering, we make sure that we have specific experts in each area. For example, design expert, component expert, product level testing expert, reliability expert, and the software expert, for example. So we have all these teams that are specializing on validation and verification of, and then, qualification of the design and the component and even the product level validation and verification. And I think that really that's the key. So most companies do have these teams on their basically on their design team. They in their development process, they have these teams. The problem is most of the time they're local to their country. They're located, for example, in US, but the product is being developed in China. So this is where it gets really, really tricky, because trying to guide the team in China, if the production or contract manufacturing, trying to guide them from far away is really, really difficult. So most likely what they do is they fly somebody's team members one by one. Somebody, for example, who is responsible for design, he will go there and meet with the production team and check issues that they have find that are design related. Later, someone from software will fly over, someone from components related, reliability engineers. So there'll be a lot of team members just flying to China, spending 1 or 2 weeks there trying to resolve all these issues and work with the current contract manufacturing to make sure that the whole production goes smoothly. But in the case of Agilian, we take control of the project. We basically do everything for them in one spot, and we make sure that we communicate very clearly with total transparency with our customers. It doesn't matter where they're located, so that they pretty much get to know exactly what's going on, what the results are, and we communicate what we're going to do. If they don't approve, we don't do it. If they approve, we proceed and we implement the process that they have approved, and then we give them results, and then we give our opinions and our recommendations on top of that. And so that's the way we operate. So to summarize, really, in order for you to go to mass production successfully, you have to make sure that you have gone through qualification of your design, components, your product, your manufacturing, and your compliance. Does that help?
Yeah, it really does. And it's a really good introduction, because somebody who has, a pretty complete prototype, for example, might be thinking, wow, we could probably go into mass production soon, right? And the answer is probably not, if you want to have the maximum amount of safety when it comes to quality, compliance, and reliability. So it's a very, very timely reminder for everybody about the level of work that needs to be done.
Right. And the key things that we focus in Agilian is that we have a very, very repeatable process where our project managers and our program managers go through every one of these methodically. Basically, it's almost like following a repeatable process. Okay, have we done any of the validation tests on the design? No. Okay, let's check out the check sheet and checklist and start actually doing it. And then whatever that needs to be done, you create a team, and the teams actually take action. These actions are listed. Once they're completed, there's a milestone review that we make sure that all of these, for every design level, every phase of the milestone, are completed before we move to the next level.
Yeah, and that's really, really helpful, especially when you frame it in the context of today with COVID lockdowns and restrictions the way they are, especially in China. Being able to work with an organization that's on the ground there is an option that is preferable to many importers who are abroad, like in the West.
Exactly. And you made a very, very good point. And the other thing that I think that we pride ourselves is that we have a whole bunch of teams that actually speak English. They understand English, and a lot of our documentation are all in English. And so everything that we do is pretty clear to our customers. We discuss with them in detail. We get their approvals before we implement anything.
Okay, great. Well, thanks very much for joining me today, Andrew. That's been a really interesting insight into what you must do before you go into mass production. And that is qualification testing. And you've been through all of the ins and outs of that throughout the episode. As we've mentioned earlier on, we've written about the MPI process before. We've spoken about it. I will leave some links to relevant materials in the show notes. So if you want to learn more, please check out the links. And also, Andrew's mentioned Agilian Technology, our contract manufacturing subsidiary. If you want to have a look at what we're doing over there, you want to speak to us and get help, I'll leave a link for them as well. And you can contact us, contact Andrew via his LinkedIn profile. There'll be a link to that also.
Thank you for giving me the opportunity, Adrian, to discuss tonight's topic. Look forward to our listeners' feedback.
Yep, great. Okay. Thanks, Andrew. Hopefully we'll get you back on the podcast soon.
My pleasure.
Thanks again for listening to this podcast brought to you by the Sofeast Group. We're on a mission to provide you with everything you need to manufacture effectively in Asia, including inspections, auditing, new product development support, contract manufacturing, 3PL warehousing and fulfillment, and much, much more across Asia's key manufacturing areas. Visit us at sofeast.com, that's SOFEAST.com, to learn more and get help. If you've enjoyed the podcast today, please do rate, review and share, because it will really help others discover us too.